Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Boluwatife who has just completed the course Linux Basics for Robotics and he'll be giving us a presentation on that. So what I'm going to do is hand over the platform to him so he can begin his presentation. Alright, whenever you're ready.
Good afternoon.
Afternoon.
Yeah, thank you very much for having me. So I recently completed the Linux for Robotics course, and yeah, I will be demonstrating my codes and
You
presenting my
can
final project.
you can minimize the Zoom screen so that we can see your screen for yes. Okay.
Okay, nice. Thank you. So first, I want to demonstrate my code on the Relay robot.
Good.
I want to, yes, yes. So I'll just I'll navigate to the directory. We have the code, source, Linux, Linux. Okay. So I'll be running the robot interface program. Okay. Yeah. So on a new terminal, I will also run the obstacle avoidance bash script.
Okay.
Yes. So the obstacle avoidance. Okay. So now the code should start running on the should start moving the relay robot around the environment. Yes.
I
Just to
think
demonstrate,
alright.
yeah, the implementation of my code. So this is the robot doing patrol around the environment without bumping into the obstacle.
Okay.
Yes. Yeah. I can also run the robot statistic program to show the parameters of the robot even as it moves around the environment.
Sure, do that. And let's
Okay.
see
So
what it moves. Yep.
okay, I'll do that in a new terminal. Goes to workstation source Linux Linux. Okay. Okay. Robot statistic. Yes. So this is basically showing the parameters of the robot, such as distance covered since start time, the current direction of the robot, the odometer position in the x direction, the odometer position in the y direction, also the odometer position in the z direction, the orientations, also the roll orientation, the pitch, and the yaw orientation. These are basically showing the statistics of the robot even as it moves around the environment. So this is my code in action.
All right. So let's.
On,
You can go ahead and open the IDE and then maybe explain a little bit in more detail what you did, especially in the obstacle avoidance one. So one understand your logic, why you made the choices that you made. Uh, you can stop execution. It's fine for on the real robot.
okay, okay, thank you very much. So I will navigate to the IDE. Yeah, this is the logic behind the obstacle avoidance script by script. Basically, some functions, getters and setters functions were implemented in the robot functions per script. This these functions basically just get some important parameters from the sensors of the robot, and they can also set some values to the actuators of the robot to make it move.
Okay.
So yeah, we basically in the obstacle avoidance robot, the logic used is we get some parameters, some scan range from the robot, from the sensors. Yes. Then we compare. Basically, what I did is initially I set the linear velocity to 0 and the angular velocity to 0 so that the robot is at a rest position.
Okay.
Then, yes, I set the threshold to 0.2 meters. This threshold is just meant to see how far or what is the distance between the robot and the nearest obstacle.
Okay.
So, yes, and in the while loop, I get the value for the 5 scan ranges: the left scan range, the right scan range, the front left scan range, the front right scan range, and the front right scan range, rather. Then I compare the front left scan range to the threshold. If this is greater than the threshold, that means the robot is safe to move in that direction. Yes. If the front left is greater than the threshold, that is greater than 0.2 meters, this 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 value will return 1, saying that the robot is safe to move in that direction. Then we also compare the front range to the threshold. If it is also greater, it return 1, showing that the robot is safe to move to the front. Also, we do the same for I did the same for the front right, showing comparing the front right range to the threshold. If it is greater, it will also return 1, showing that the robot is also safe to move in the front right direction. Now, using these 3 parameters, there were 8 different cases that we can compare. So, yeah, 8 different cases. So these are the cases. Each of the cases, we decide what to do. The first case is when the front left is free, and the front is free. No, rather, 0 means not free. 0 means not free. 1 means free. So this first case is saying when the front left is not free, the front is not free, and the front right is not free. Then what should the robot do? The robot decide to move either in the left direction or in the right direction. So yeah, the robot compare the left scan range and the right scan range. Which of them is greater? Then it moves in the direction of which is greater. If the left is greater than the right, then it turns left. How does it turn left? It sets the angular velocity to this value, 0.942477. To
How
make
did you
it,
choose that value? Did you just get the one that was provided, or you had to tune it?
yeah, I got the value from the instruction.
Okay, all right. So you didn't try to optimize it for your use case. Okay.
Yeah, though I changed the value a bit in the later part of the code, I just changed to 0.90 because I noticed that the robot was turning too much. It was making too many rotation. So I reduced the value a bit to 0.90 to reduce the rotation.
Okay.
Yes. So if the left range is greater than the right range, then the robot turn left by setting the angular velocity to this value. Else, if the left range is lesser, then it turn right rather by just setting it to be negative of that same value. Then I made it sleep for 1.5 seconds so that the actuator can complete the action, the turning action. Then I set the angular velocity back to 0, so I can check the next case. This is the second case when the front left is free, is not free rather, and the front is free, is not free rather, and the front right is free. If the front left is not free, yeah, the front is not free and the front right is free. That means this robot is safe to turn right.
Okay, so you have all the 8 cases following the same structure.
8 cases.
Okay. All right.
Yeah, all the 8 cases. So depending on each of these cases, the robot takes its decision. So in this case now, it turns right by just setting the angular velocity to this value. this is what I was saying earlier, that I reduced the value when I noticed that the robot was turning too much.
Okay.
Yes. So in this case, I made it turn. I set the value to 0.902477.
All
So
right.
then I made it sleep for 1.5 seconds, yes, so that it can complete the action as well. Then set the angular velocity back to zero, because the robot will continue to execute whatever command is given until another command is given.
Yes. Okay. I see. I see. All right. So let's
Yeah.
speak a bit more about the Linux stuff, right? So I've seen you navigate into various directories and executing some scripts. So on the basis of what
Yes.
we've been doing at the moment, there are some scripts that I've seen have got permission to execute. For example, your obstacle avoidance script. If you were going to remove execution permission to one of them, how would you do it? Can you demonstrate to me how you can do that?
Yes, I will just use the change mode command.
Mm-hmm.
The change mode command. If I want to remove execution permission, I will. Okay, let me try to demonstrate that.
Mm-hmm.
Let me take it back to the terminal. Okay, let me use the new terminal. First, I will navigate to the directory. Sorry, sorry. Was to then source.
Mm-hmm.
So this is the directory containing the file. If I want to remove execution permission from, let's say, a simple patrol.batch file.
Let's do one that's not running, unless you're sure that one is not executing at the moment.
Yeah, this particular file is not executing at the moment. This
Okay.
simple
All right.
patrol will. Yeah, I will just use the change mode command.
Mm-hmm.
Change mode command stack x. This means remove execution permission.
Mm-hmm.
Then from the simple patrol wheel dot batch. So if I list the file in directory now,
Mm-hmm.
I will see this particular file is now painted white.
Mm-hmm. What other
Yeah,
methods of
showing.
checking for permissions can you use instead of the colors, for example?
Okay, if I want to check, I can just use the the long list, instead of just listing the files in the folder. I can long list the file in the folder. It will also show me if there are permission.
Mm-hmm. Okay.
So if I do this now, X means it has execution permission.
Mm-hmm.
Yes. So for this simple patrol wheel program, it no longer have execution permission. It only have read write permission.
Mm-hmm. Mm-hmm. And can you also
Yes.
explain why we have multiple X's, for example, in each one of them, or why we have multiple R's, right? What does that mean?
Yes. That means each of them means
Mm-hmm.
different permission group. Yeah.
Okay.
The first one is for the owner.
Mm-hmm.
Yeah. Sorry. My section ended with the booking. It's trying
No
to
worries.
disconnect from the robot.
All right.
Yes.
All right. We'll continue after. You can just
Okay. Yes.
list the files again and then continue with the explanation.
Yeah. Sorry, my terminal is trying to start again.
Okay. Okay. I'll give you some time.
Yes. Thank you. Okay. So I'll just navigate back to. Yeah. So okay. Yes. So each of them represents different groups.
Mm-hmm.
The first is the owner. Yeah. The second is some group, like some groups that has been given some permission.
Mm-hmm.
Why the third is other users. Other users. So first this first indicates that the owner has read permission write permission, and execute permission.
Mm-hmm.
Yeah, this second is indicating that the owner has the other groups have execute permission and read permission. Why this third indicates that there are other users have read permission, write permission, and execute permission. So each of them just represents the groups.
Okay, very, very good. So each of them represents various groups and the permissions that they have been given. Very nice. All right,
Yeah.
all right.
Yes.
So in comparison to, I believe you also ran the same obstacle avoidance script in simulation, right? What did you notice? What were the differences that you noticed? Did you have to make any changes, and what changes did you have to make when you transitioned to the real robot?
Okay. It's I actually run the obstacle avoidance bash script on simulation, and it works quite fine.
Mm-hmm.
So I didn't make any changes. I just run the same program on the real robot also.
It's good. It worked.
Yes.
It worked right away. Sometimes you have to make some changes. All right. So
Something. Yeah.
if we are going to improve your script, your obstacle avoidance script, can you tell me
Yes.
maybe two or three things that you would do?
Okay. Basically, I will, instead of just randomly setting parameters, especially this angular velocity,
Mm.
I might want to do some calculation on how I should turn. What value? How can I have a perfect 90 degrees turn?
Mm-hmm.
How can I have a 45 degrees turn?
Mm-hmm.
So basically, that's one way to optimize this script.
So you would
Also,
want your robot to turn in a manner that is proportional to the obstacle that it has encountered and wait it finds itself.
yeah, instead of just turning randomly, with a random value like this, even though I didn't know how they come about this value,
Mm-hmm.
but I think I can do some calculation and come up with a specific value also.
Mm-hmm.
So I think that is one way to optimize this code. Another way to optimize this code, because we are checking 8 different conditions.
Mm-hmm.
Eight, we are checking 8 different conditions, and some of the conditions the might be free in 2 different cases. Maybe the front is free and the
Yes.
front left is also free.
Yes.
So yeah, in this kind of condition, we don't really know where to go at the moment. Maybe we compare the front left and the front. We compare their scan range. So instead of directly comparing, I think we can try to see the current location of the robot. If it's trying to move to the front, it will continue that movement since front is still free. Instead of trying to turn at that moment. I don't know if you understand what I'm trying to say.
Mm-hmm. Mm-hmm. All right. Makes sense. Makes sense. All right. So
Yeah.
with regards to calculations, right? One last question. Can
Okay.
you explain to me the limitations of the base script and the choice between having to compute using float point numbers and integers, right? So clearly you must have encountered something along those lines. Can you explain to me what are the limitations? So let's look at
Okay.
line 52, for example, right? You have to specify that you need to use basic calculator, for example, and then you put stroke L in front, right? Can you explain to us what is the logic behind that?
Okay. Okay. If I should get your question right,
Mm-hmm.
said I should explain why I put BC stack L.
Yes, yes. In basic terms, yes.
Yeah. This is basically a mathematical logic that allow, even though I didn't really make research like instruction from the logic that
I,
I
Boluwatife,
don't know if I'm right or wrong.
can
Please,
you
you
say that
can
again?
let
I
me know
think your
if I'm
answer
right.
wasn't coming through clearly.
Yeah, hello?
Yes, now I can hear you. I was saying your answer wasn't coming through clearly, so we could see your audio, but the vocals were chopped up.
Okay. Yeah, I can hear you better now. Sorry. I think there was a little network glitch.
Okay, yeah. So you can go ahead and explain one more time.
Yeah, I said I didn't really make research on this syntax, this BC stack error, but I think it is just a mathematical syntax that allows floating points. So I don't know if I'm right or wrong. Maybe you can correct me if I'm wrong.
Yeah, you're right. But normally I would recommend that you check it first, right? Obviously you're making use of some code sections that were provided to you, and it
Yes.
you have to take the responsibility to try and understand what is going on, how they're doing it. So, um, but so far so good. You've managed to make use of that stuff in a very convincing way, and also very um, in a way that works, right? That's the most important thing, right? Just make sure you
Yes.
polish some of the things that are a bit missing. But anyway, thank you very much for
Thank
your
you.
wonderful presentation, Boluwatife, and wish you all the best. So, can you just hang around? We're going to wrap
Okay. Thank you very much. Yes.
All right, everyone. This was Boluwatife's presentation, and I'd like to encourage all those of you who have not tried this course to do so, and then you can also come and showcase your work or any other one that we offer certificates on. All right. So until next time,